All right, so welcome back to this quick lecture. First of all, a quick apology for the bit of delay to upload this recording. I also want to clarify that usually MOBISEC has always been 12 lectures. It's going to be the same this year, but since there is this remote setting, I also want to give some extra material to compensate the fact that I'm not there. And so that's what today is about. So it's going to be a short one. I think about 1 hour, 1 hour and a half, and I'm going to focus on 3 different things. The first one is I want to finish up what I started in the demo in the first class, the live one, because basically we were cut short. There was not enough time, so I have a couple of things I want to show today. Then I would focus on a demo on the material last set of slides. Where basically we're going to check, taking an APK and then, how to unpack it and how to read its content, like the manifest, where is the bytecode, or where are the resources and so forth. And then we're also going to play with the bytecode. Okay. So what I would like to teach today is more how to become independent in understanding how different things in Java translate to the Dalvik bytecode. And that's basically, how we build a foundation to actually be able to go back. Like we take an APK that we don't know about, we take the bytecode and then we somehow read the bytecode and then we try to go back, understanding what the app is doing or what could be the JavaScript that actually is producing this kind of Dalvik bytecode. Okay. The third thing is more a quick demo on how to debug and approach reaching out challenge. Many students have had issues with this. As of now, it's listed as the second easiest challenge. Probably it's a mistake on my side. Like if you know HTTP, then maybe it's easy. If you don't know it, maybe you can get a bit lost. So today I try to compensate on that. And again, I've seen many emails about this challenge, and many of these emails kind of they tell me that you guys are guessing a lot. This is HTTP. HTTP is the foundation of the web. So it's really well defined. There is no guessing on how you should talk to the HTTP server. Okay. But anyways, I'm going to have some words on that aspect. Okay. All right. So we start with this finishing up the demo that I started last time. And the only thing I was missing last time is how to start a different activity. We already covered this in the slides, of course, but there is one syntax I think that I showed in the slide that is useful to start activities inside your own application, but there is another syntax that you need to use to start activities that are outside your application. Of course, Google is your friend. This is not a secret, so you could check it out. But since it is a very basic thing, I want to do my part and show this to you. Okay, so as a first step, we start. We want to start an activity in our own, another activity in our own application. So what you see here is what we ended up being at the last demo, at the beginning of the class. And so what I want to do is that we write the app so that when we press the button, when we click the button, we start the second activity. So first off, we need to create the second activity. How do we do this? Well, usually what I do is to go here, for example, the package name, and then I do new, and then I do activity, and then I do maybe basic activity. Okay, and we call it boom activity. That's our target, and we finish. Okay, bam. Okay, so this is gonna be looking similar to the first one. So I think we're gonna see a different name here, like the boom activity. So we're going to be able to distinguish them, but just let's see if I can quickly add maybe a button or so. Let's see. Layout be here. Okay, let's try like this. And then if we don't recognize it, we're going to modify this so that we recognize this is the second activity. Okay, so now the second activity exists. Let's check what the automatic things did. It didn't do much more than, first of all, it creates a new class that extends upon activity, which eventually extends activity. And then it creates an onCreate method with already some code. And this code basically does set the content view. And content view is an XML file that defines how the activity looks like. And that's where it's defined. And if we want to see how it looks like, the XML file, a common trick is to press Control, at least on my Linux box, and you click on this. It's going to link to the XML file that that somehow is basically setting what you would see as an activity. Now you could tell me, but this doesn't look like an XML file. Well, Android Studio is very nice, so it takes the XML file and it renders it, and it shows you how the activity will look like. Okay, if you really want to see the XML file, you click on this text, and that's how it is. Okay, cool. All right, so we go back. The other thing that this automatic Android Studio create activity did was to modify the manifest and add the second activity here. And again, this is important because to be an activity recognized by the Android framework is not enough to just create a class that extends another class, okay? You need to really specify it in the manifest. Otherwise, if you try to start an activity, the Android framework tells you there is no such activity, okay? Cool. Now at this point, let's see if this Android Studio thing created everything in a way that is still compilable. So I press play, run task. Okay, so it compiles and is not crashing. Perfect. And again, if we press here, nothing happens. Now we go main activity, and we are gonna create the target, the start activity. So first of all, we create an intent. Again, an explicit intent that defines which activity we want to create. We do new intent, and then we do okay. Another chance to explain this thing. See, the syntax we're going to use is this: package context and then the class type. Okay, so this is a bit tricky because I often get this in emails where I say, but I need to get a context. How can I get a context? Well, the context is some kind of magic object from Android that allows you to get resources, get activity manager, get things like this. Okay, and in many cases, to transition to different activities or to do things like this, you need to have a reference to a valid context object. The trick is the following: the main activity you have, so this pointer to this activity is already a context object. How is it possible? How can you possibly know? Well, if you check main activity is extending up compact activity. If you check in the code or in documentation, you're going to see that this activity is actually extending also the class activity. And again, if you check the docs, you're going to see that the class activity is eventually extending also the context object. Okay, so somehow the common trick is, if you are in an activity, tries to get this pointer to the activity. If you are not in activity, maybe pass this pointer to the activity that somehow is invoking your function, so that you have access to the context object. Okay, now, so if we are here, this is already a valid context object. But where you are here, it's a bit trickier. Why? Because we are not in the onCreate method, we are in the onClick method. And the onClick method is not a method of the main activity. So if we do this is actually a pointer to the onClick listener class that is implemented this onClick method. Okay, so it's here the syntax is a bit tricky because we're basically creating an inner class, which basically we are creating a class inside another class, plus it's anonymous. Okay, because here we are doing it like inline, new view onClick listener, and then we define it. An alternative would be to create a class that extends view or onClick listener, and then we create an instance of this class and we pass it. In this case, we do both in one shot. Okay, so we have both an anonymous class and which is also an inner class. In Java, there is a trick to get a reference to the class outside your inner class. Okay, and the trick is the following: you name the actual outer class, and then you do .this. This is a valid reference to a context object. Okay, and in many cases, that's what you need to do. Okay, then the second argument was a class type. That's easier. We just need to do boom activity dot class. Bam. Okay, and that's it. Now we have this intent. We need to send it. We do start activity intent, and I think this should be it. So let's try it. Play. All right, and now we try to play it. Fantastic, it works. Okay, boom activity. All right, this is the first part. The second part is, what if the activity you want to start is outside your application? And this, of course, happens many times in the homework. Well, the way to do it is to not use this syntax. This syntax is tricky because here it requires to have this boomo activity.class. But if the target activity is in another application, you cannot just type the name of the class, the receiving activity .class. You know, because this name is probably not even is not included in your application, you cannot resolve it and so forth. So there is another way. What I usually use is to use a component name. Okay, so let's see how it's done. Comment it. So another note before I do it. What I'm gonna show it to start an activity within the same application, but the syntax allows you to start activities in another applications. Okay, and it's going to be clear once I do it. So component name cn equal new component name, and then we need to specify the package name and the target activity name. Package name. So the package name again is the package name of the target app. In this case, you know, when you need to interact with the target app, usually you know it. So in this case, we set up the package name of the same app for the purpose of this demo. And so this was the package name, bam, 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 bam. Okay, cool. And the class name, we just put the class name, which is boom activity. So this should be a fully qualified name. Okay, so if boom activity is in this package name, we need to write this package name dot boom activity dot boom activity. Again, a couple of things. The first one is, since this boom activity is defined in a package name that is the same package name we are defining here, you could even write here dot boom activity. Okay, so the fully qualified name is not strictly necessary, but you know, now you know that you can do this. The other thing, I got some emails from students. They figured out this component name trick, but they somehow kept including dot class here. You don't need to do this. The dot class is just a trick. It's like something from the Java syntax to get a reference to the class type of the class. Okay, so you don't need to do it here. Perfect. And now we do okay. We do intent. We create an intent without anything basically, and now we do set component cn. Okay, and that's about it. So it should work. Let's see. Cross your fingers. All right, and bam, boom. All right, so it worked. I think, yeah. So for this easy part of the thing, that was what I had in mind. Again, are there any questions? I cannot hear any questions. No, there are no questions. Fantastic. As always, please feel free to email me for questions, and maybe I'll do a follow-up video if something is not clear. Okay, so going forward, what I would like to focus now is to play a bit with these tools that I discussed last time. So given an APK, how we can we disassemble it, unpack it, and inspect it a bit, and so forth. Okay, cool. So let's start by somehow grabbing the APK that I just compiled for this one. Get a shell. Hop. All right. Okay. So we go, I think, in this folder, Android Studio project, and then this app was called MOBISEC Zoom Noob Demo. Perfect. And now we try to locate the APK. And here it is, build outputs apk.debug. Fantastic. Now we have the APK. Now, Let me see what I've written. What I want to show you, first of all, is that we can just unzip it. Somehow I said that the APK is a zip file with some content inside. So let's try. Unzip app debug. Okay. We have a bunch of stuff. Oh, we have Android manifest, classes.dex, very interesting things. Resources. Okay, we have the extension. Let's try to open it. Android manifest. It looks very bad. Why does it look very bad? Because I mentioned last time is the APK, sure it's a zip, but it contains compressed files. So the Android manifest XML is an XML file, but when it's stored in the APK, it's actually compressed. Same stuff for the resources. Resources, there is this file that somehow are compressed resources. Let me see in this res. Interesting. Layout. Let me open something. Each XML file, even in the resource, is also compressed, okay? So they're not really readable, not very useful. So what do we do? Before going to the main tool to actually take care of this, there is one thing I want to show. That is, check this out, classes.dex. Classes.dex is somehow the file that contains the actual bytecode, okay? So there are two tools called Smally and Smally that are somehow useful to go from this classes.dex file to the somehow human readable version of the bytecode, which is Smally, which is what I explained last time. Let's try to use it. Smally. Again, how to install it, Google for it. It should work for Linux, Windows, and Mac, and so forth. Class.dex and maybe -o for the output, and then Smally. Okay, now we do Smally. Bam, we have a bunch of stuff. And let's see, what was our own package name was comtest. Oops, comtest MOBISEC Zoomer test. Perfect. You see, basically this Smally gave us a human readable, we didn't see yet, but basically we have for each package name we have a folder, and then in each folder we have the actual .smally, and we have a .smally for each class. Okay. For example, we should have, yes, main activity .smally. So let's open it up. Bam, inside we have Smally. Okay. So now you understood the trick to basically learn this stuff. That's all you need. You start from a Java application, and then you should ask yourself, oh, but how do they translate this feature of Java in Smally? For example, what if I have a if statement in Java? How does it look like in Dalvik? For sure, there should be a match for every Java thing you can come up with. There should be a match in the Dalvik bytecode. Okay, for sure, because of course these apps are shipped with Dalvik bytecode. They're not shipped with Java, so there should be a match. And you know, you can ask yourself so many questions, and in every case you can answer these questions by try yourself in Java, compile it, and then unpack it, and you see how the Smally looks like. You can do this with, oh, but how do they support this type? Or again, if statements, or switch tables, things like this. Okay, or loops, or how to start an activity, or how to create an intent. Really, it's up to you to somehow asking yourself questions and then try to get an answer. What I provided here is just the tools and the mentality and the mindset to figure this out. Okay, so a couple of comments on this. Here we see, okay, it starts with .class and then the access modifier for the class and then the name of the class. As you can see, they use the syntax I explained last time. L for defining, oh, this is a type, let's say user-defined type, not user-defined, but is not a built-in type. Start with L, and then you have the actual fully qualified name. So package name and class name and semicolon. Okay, this identifies the type main activity, and you know what kind of class we're talking about. This tells you, .super tells you which class you're extending. Okay, and you may ask, oh, but what if I'm implementing an interface, which is a different keyword in Java? Well, figure it out. Try to write a class that implements an interface and try to see how Dalvik looks like. Okay. source, this only if you have the bug symbols. And then look at this stuff. Constructor, this dot method tells us we're starting to see the Dalvik bytecode referring to a method, okay? And here it ends with n method, okay? So here is the code of which function this less init greater. What is it? Is a constructor. So if you have a constructor in Java, that's how it looks like in Dalvik bytecode, okay? And it doesn't do much. I think it just invokes the constructor of the class extends. And here, for example, we can find implementation of the onCreate. And you know, this stuff looks weird. Invoke super, invoke virtual, const of big number, blah 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 blah. This stuff is how our code in the onCreate is actually implemented in Smiley. Okay. For example, here you can see, look this up. We have a const string MOBISEC. So here we're putting the string MOBISEC in v1, here we're putting the string Peppa Pig in v2, and here we are invoking a static method that is log.t. Okay, that's how we are calling the logger, and we're passing two arguments, v1 and v2, and the two arguments are MOBISEC and Peppa Pig. This is the tag of the log, and this is the actual argument of the logger. Okay, so you can find the match between your Java code and your Dalvik bytecode code, and so forth. Okay, here you can say we call another thing, and then we get the result. You see where I'm going with this. Let me see my notes. Okay, now the cool part about Smiley is that it's human readable and you can modify it. So as I'm gonna show in another demo in the future, we're gonna see how one of the technique to actually instrument applications is to unpack them. Take the Smiley, you insert your own things. For example, you can insert a thing that is going to log something to lotcat, and then you repack it, okay? And how to repack it? Well, there is another tool called Smiley. Such a great fantasy. Let's go back. And we do Smiley, and then back Smiley, and I think it should be the show, new classes.x. This is the output. Let's see if it works. And it works, okay? So now what you could do is to take this new classes.x, you call it classes.x, and then you repack the application, okay? But you know how to repack it, and we still need to figure out how to redesign the manifest. All right, so that's where another tool kicks in, and that's APK tool. I mentioned this in the slides last time. Now we're gonna have a demo on this. First of all, I made a mess, like there are many files here. So let's create another folder. MD is just my alias for make deal. Add the bug in demo. Okay, now we do APK tool. D stands for the code, which APK, and then which folder we want to write the unpacked stuff here. We do here. Okay, and bam. If you go in here, we have something that looks like what we've seen before, but now things are different. For example, the entry manifest is actually unpacked. So we actually see textual thing, and we can see things like, you know, for example, activity, where it is. This is activity under name, MOBISEC zoom, main activity, and we have intent filter that defines main launcher. So we know this is the main activity, and then here we can see also the boom activity, com-test, MOBISEC, boom activity, okay? And the cool part is that to see this information, you just need an APK. So you can do this with the Facebook app, with the, you know, Pinterest app, or, you know, the Justin Bieber best fan app, whatever app you want. You take the APK, you can run this tool, and you can read this information about the app. You can know what's the main activity, you know, and, you know, if you build on this knowledge, you really have the tools to understand how an app works and to modify it at your pleasure, to repack it, and you can install it on your own device, okay? Again, how to repack it and things like this, how to modify it in an effective way and so forth. We're going to see this later on, but you get the point once again. All right, other things. Let's see, in Smiley. Well, Smiley looks like what we've seen before. test MOBISEC zoom. This is basically exactly the same. My understanding is that APK tool uses under the hood Bagsmally, so there is no surprise that this looks similar. If it doesn't use Bagsmally, probably integrates the code base, but you know, that's the same stuff, okay? And then we have res, these are the resources, and now we're gonna see something different. These XML are actually human readable. For example, you have strings XML and you have all the things that the human can read, okay? So everything is uncompressed. Fantastic. All right. The other thing is there is equivalent of building an app. And the way it works is that we do APK tool. B stands for build, the folder, and then the current output. Peppa.apk. And that's it. Okay, now we have peppa.apk. And we can install it. Let's try. Let's try first to install app-debug. It says, oh, you know, it's still fit test only. Okay. That's actually a very common problem that many students had. I'm gonna show how to fix it. Probably you figure it out. But what I want to show you is that if you try to install this one, it's gonna work. If you try to install this peppa.apk, it's not gonna work. Why? Because it's not signed properly. Okay. And so that's something that we're going to explore later on how to practically do it. When we're going to see, you know, you take an app, you reverse it, you modify it, you pack it, and so forth. Okay. So even if you fix this test only, if you try to install this peppa.apk, it's not going to work, and that's expected. And again, we're going to have a future demo covering this this aspect. Okay. Cool. But apart from the signature problem, this is a valid APK. Okay. You can really, after you sign it, you can actually install it on your device, on your emulator, and so forth. Okay, cool. All right, so what I want to do now is to go through a couple of examples of more difficult stuff you write in Java and how they look like in the Smally. Okay. For example, let me see my list here. All right. First of all, when I do this test, I usually try to create a method that I know has a specific name, void Peppa, so that I know where my test code is going to end up in the Smally. Okay, because we're going to have main activity to Smally, and then I just grab for Peppa and I'm going to find it. Okay, and let's try to do some other math. So let's say int a equal 3 plus 4. And then int b equal a plus 7, okay? And then let's say we return b, and then let's say that this Peppa, perfect. And now we build it. Build APK. All right, so app-debug.apk should be the new one. So let's try to unpack it. The APK tool, -d, app-debug, -here. I should not have unzipped that thing there, super dirty. All right. Here, and then let's check. Okay. Here, Smally, com test, MOBISEC main activity dot Smally. Bam. And then we look for Peppa. Bam. All right. And so now you can see. Basically, we have a interesting 3 plus 4. We just have a 7 here. So it's a coincidence that there is a 7 here. But what's going on is that somehow the compiler optimizes out, and so 3 plus 4 is computed. It knows it's 7, and it just put move 7 in v0, and then you see add int instruction that takes whatever is in v0, which in this case is a, he adds again 7 and he puts in v1, and then it somehow returns v1. Okay, and here you can also see how you have the dot method. Okay, public, we know it's public, and then check this out. This is the full signature of the method. So in this case, there is an empty thing. It means it does not get any argument, and then there is an I. The I stands for integer, so we know it returns an integer. Okay, let's try to complicate this up with some more complicated method. For example, let's say protected, and then let's say let's say, okay, I have an idea. Let's create a new class, Java class, and let's call it foo. Okay, and let's create another method called, I don't know, ham, and then we just, you know, return ham, and maybe here we return a string. Okay, and now we can, maybe we have another function that returns an object of type foo, and we call it get foo, and it takes maybe 2 integers, and we create new foo, and oops, f, and now we get well, for example, we could log MOBISEC f.hem, which is going to return a string, and then we can do return f, for example, which is going to be of type foo, so everything makes sense. And now let's try to build it, and let's try to see how things look like. Is it building? Yes. So I remove the here folder. I'm getting ready to, okay, he did it. I decompile again. And then I open it up. All right. Peppa, okay, Peppa. After Peppa, we should have, where is the get foo? Perfect. Here it is. So get foo. Okay, first of all, let's check the signature. Okay, protected, so we know it's protected, as is written here. Then there are 2 arguments, I and I. Well, there are 2 integers, and then look at this, lcontest foo. That's how it specifies that the return type is of type foo. Fully qualified name, it starts with an L, it ends with a semicolon. I'm being picky about this because once you need to modify this app and injecting your own Smiley, as again, I'm going to have a future demo, but you know, my point here, you should pay attention because you need to put the semicolon, you need to put the L, so you need to know exactly how things are expected to be for being valid Smiley. Okay. Okay, gets I and I. Again, here we see some kind of debug information. Usually you don't have them. And then let's see. In our function, we are creating a new instance of a class foo. Looks how it's done. First of all, it creates a new instance of, you know, it puts it in v0, and this is the type signature of the class. And then looks at this, it calls a constructor. So somehow when you do new foo, it's not just creating an instance, but it's also calling the constructor. What happens here is that the new instance is actually reserving the space in memory to contain something, to contain a valid instance of foo, but then it needs to be initialized, and that's when it happens. It calls the init, okay? And again, this is a normal method. It's called init, it's the constructor, but it's a normal method. So v is because it doesn't return anything, stands for void, and it's empty just because this constructor doesn't get anything as input. If you had arguments, of course you will see them there, okay? So let's move on, and now you see, aha, look, here we're calling log e MOBISEC f.m. So of course the compiler needs to take this and split it in different components. And so what it does is first it calls f.m, and now it's ready to call log e, okay? And we see this here where basically, okay, let's try to first check where it's actually calling the log, and then we go backward. That's the usual practice. So first of all, here that's where it calls the log.e, okay? And it takes 2 arguments, the log.e, a string and a string, we knew it. It returns an integer, I actually didn't know. And the first string is a tag, the second string is the actual log message. And going backward, we see that the first tag, the tag is basically v2 and the message is v1. v2, what is being said to v2? Well, we go back and we are lucky in the next instruction going backward, we see that in v2 it just puts MOBISEC string. Okay, makes sense. That's the tag. And then what is v1? Well, v1 here, there is move result object v1. If you remember from the slides, or if you don't remember, just Google for it. Move result is a special bytecode instruction that says whatever the return value is of the function you called in the line just before me, then put it here. So this v1 basically contains the return value of the method that has been invoked in the line before this move result, which in this case is this invoke virtual full hem. And again, full hem, foo is the class, hem is the method. Hem does not take any argument and returns a string. Kind of makes sense, right? We can see it here. Doesn't take any argument, returns a string. Bam. And then v0, what is v0? Well, v0, you probably guessed it, is this instance of the foo object on which we're calling hem. And if you go backward, you should be able to see that v0 actually is of type foo. Okay? And in fact, in the line before, we now understood that v0 is actually type foo. Another interesting thing of this Dalvik bytecode is that all the types need to match. If the types don't match, the verifier is gonna throw an error, so your app cannot run. What do I mean with the types needs to match? Well, I mean the following, that if there is a invoke virtual v0 on this foo, and v0 is supposed to be this instance for this call, well, v0 better be an object of type foo, otherwise it's not gonna fly. Okay, in this case it is. That's where we discover that v0 is of type foo. In other instance, for example, v2 and v1, they both need to be strings. Well, v2 is actually a string. v1, is it a string? Well, check this out. Move result object v1. How do we know the type of v1? Well, check the instruction before. And we see that the return value of this invoke virtual is actually Java lang string. So everything makes sense. Now, in this case, everything makes sense because it's the Java compiler that generated it. So of course it makes sense. If you modify the Dalvik bytecode yourself, you need to make sure that all these checks make sense. Otherwise, you're gonna see an error. Okay, cool. Of course, while I was learning this stuff myself, I of course did many mistakes, and sometimes you're lucky, you do the mistake, and then it tells you, oh, I was expecting type X, but I got type Y. So a kind of nice error from the Dalvik bytecode verifier. Sometimes you are not that lucky, and so it just crashes and you don't know why. What you need to remember in these cases is to have trust in the system, in the sense that if it crashes, there is a reason, always. Okay. Once the Android Studio produced bytecode, it always runs. Okay. I don't know any case where the Android Studio produced a bytecode that is not valid. So somehow, if you took valid bytecode and you modified it and now it doesn't work anymore, well, you did a mistake. All right. So believe me, I'm repeating this because sometimes you somehow lose faith in all the gods you believe in. So there is always a case. There is always a reason why things don't work. So if they don't work, sit down, try to figure out what's the optimal way to figure out what doesn't work. Usually it is step by step. So if you have a big modification of the lines, well, maybe just do one and see if this one actually works out. And if it does, well, 2, then 3. If you want to be super optimized, maybe do binary search. If you have 10 lines, just try with 5, and so forth. Okay. That just to give some advice. Of course, there is no single recipe. It's like sometimes like is an art to figure out this stuff. But again, you get the idea. All right. Let's see other things I want to show. Okay, we did method call and okay. Oh, where do we find the implementation of foo? Well, we expect to see now a foo.smiley. Here it is, foo.smiley. Bam. Very simple. Constructor is always there. And then, hem, just define v0 with hem and then returns it. Very easy. Okay. All right. Let me see what I have in my list of things to show. All right. So I have three things. We'll see. We'll see. One thing I want to show is loops and if instructions. Public void test with loop. Let's do a simple loop. Let's do int equals 0, and then we do while I less than 10. Then, we do MOBISEC. Boom. Okay. Very, very simple. And now maybe we write here. Hope we are done. And maybe we write here. We are starting. Hop on. All right. And so now we build it. And it's built. I open it again. I grab for test with sorry, we need to unpack it. First of all, let me remove here the code. Perfect. Hop, and then test with loop. Bam. And now let's see. Okay, first of all, we have the log of the we are starting, kind of makes sense. And then let's check this out. So somehow, okay, here it puts 0xa, which is 10, in v2. And then it checks if g is if greater or equal. So if dv0 is greater or equal than v2, then jump to condition 0. And condition 0 is here, and it is constraint we are done. And here we're basically dumping and printing we are done. Okay, so somehow it's pretty easy. Let's figure out what is v0. Well, v0, it needs to be defined somewhere. That's another constraint the verifier enforces. v0. Okay, it was defined here. v0 is equal to 0. Okay, so somehow the logic is the following. It put 0 in v0 and 10 in v2, and then it says if 0 or if I is greater or equal than 10, then jump out. Kind of makes sense. It's the inverse logic of this while. If this is not verified, then it goes through and then it prints boom. It said boom here and then it just prints boom here. Okay. And then at the end, bam, it goes back and it jumps again to the check. It puts again 10 and then it check whether the current variable I is actually greater or equal than 10. Funny thing, I just noticed I did not put the I++, so this is going to be an infinite loop. I was looking for, where is the v0 equal v0 plus 1? Well, there is no, because I did not put it. Okay. Of course, if I would put it, then of course after here you would see, add integer or something like this, v0, 1. That's where you did it. The other thing I want to show is that why is this putting 0xa into v2 again? 10 is never going to change. Well, if you check here, v2 is actually reused. And is going to use to be the message of the log invocation. Okay. So somehow what you can see here is that each register can actually point to instances of objects of different types. Okay. So it's not that each register needs to point to only one type of object. The constraint here is that once a register is used, then the type should be consistent with what the user is expecting. And in this case, it's verified because, for example, here we are using v2, which needs to be a string. Well, we defined it as a string in the line before. Here we are using this as an integer comparison. Well, it is defined as an integer in the type, or integer or a compatible type in the line before. Okay, so everything makes sense. If at this point, if the compiler would put this v20a outside the loop, so here this would not work, because the first time it works, because v2 is defined at 10 and then here is 10, fine. But once you go back here, then you are gonna end up with v2 that is modified with a string, and this is not gonna fly. I'm pretty sure this is a mistake that would be caught by the verifier, because it checks that in every possible path, the types are actually making sense. Okay, but again, keep this in mind. Cool. As you guessed it, maybe if instructions or things like this are going to be handled in the same way. All right, other two things. One is the concept of inner class that we somehow encountered already. So here in this one, on click, I mentioned that on click is actually not a method of the main activity, but is a method of the inner class, which is constructed by this new view in on click listener. Now, an inner class in Java is a class defined inside a class. And here it's a bit more complicated than this because it's a class that we define in line, like we don't even name it, okay? And the question you should have in your mind is, where is the onClick method? If it's not a method of main activity, it should not be in main activity. And if it's not in main activity, where is it? First of all, let's verify that it's not in main activity. OnClick, okay, we have some hits. This is more the setOnClick listener, which is a method that is invoked in main activity, so it makes sense. Let's continue the search. There is nothing. So the only on-click hit we have is the setOnClick listener, again, which makes a lot of sense. Where is the inner class? All right. So Smiley has a way to call these classes, and the way is the following. See, there is main activity .smiley, and then there is main activity $1 .smiley. Basically, what Smiley does is to create another class, and that's actually what's happening under the hood. It creates a different class where the name is the kinda outer class $1, $2, $3, depending on how many inner anonymous classes you have. Okay, so in this one, we're gonna see somehow a class implemented on click. Let's see if it's true. And okay, class name is this main activity $1. And look at this, is interesting. First of all, it extends the object. Okay, object is the kind of parent class of every class in Java. So if you don't extend anything, you always extend from object. And look at this, bam, implements view on click listener. Two interesting things here. The first one is that we have seen how, if you take a class and you implement the interface, that's how it shows up in Dalvik. It's going to have dot implements and then which classes you implement. In Java, you can implement more than one, so you can have, I don't know if he puts a list, I think he puts a list, okay? The second thing is, if you check the name of this is view $on click listener. What's going on? It's going on exactly what we're seeing here with the $1. So the dollar somehow, so the on-click listener turns out is an inner class of the view class. So there is the class view, the class view in the defining entry framework, and then inside the class view there is the class on-click listener. Okay, and somehow Java and Smiley use this dollar syntax to specify that this on-click listener is an inner class of view. In this case, we have $1 because the inner class does not have a name. It's an anonymous class. We create it in line. Okay. So here, this main activity $1, it's a bit complicated because we are mixing two different kind of not trivial things. Now, if you move on, we're going to find the constructor and then finally the onClick. Okay. And onClick is treated as a normal method. So we have the method and then we put a string here, we replace with your own activity, we replace with your own action, sorry, and blah, 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 blah. Okay, so that's all expected. That's where we put the log and so forth. Okay, so now you also know what happens to inner activities. The last thing I want to show is about resources. Let's see. Check this out. I mentioned this in the slides already, but it's, let's see it live, let's say. Here we're going to have set content view, and then we have r.layout.activity main. Now, if you check documentation, set content view, I'm pretty sure it accepts an integer as an argument. Okay, not a string, not an XML file, an integer. Okay, let's check it in the bytecode. Smiley. on create. Okay, and now we have set content view here. Okay, and again, it accepts an integer in. Let's see which value this integer is getting. Well, v0 is getting, what is this? 0x7f blah blah blah, eyes out. As I mentioned in the slides, what's happening is that for some of the resources, and this is like a layout, but you have the same things with strings. Sometimes you use resources, and for example, for a string, you can create a resource of type string, and the resource will be, the string will be Peppa Pig, for example, and the way you use it in the code is r.string.the keyword. Okay, so in this case, it's a layout, so we have r.layout.activityMain. The question is, how can we find from this weird number, how can we find the correct entry to figure out, okay, this number matches to activity main? Well, there's a trick. We copy it, and then we go in here, we go in resources, and what you should do when you are guessing what's going on, you grab for it. Bam! Turns out there is a values, there is a public.xml, and this somehow the mapping, where the mapping is, that maps IDs, so this number you see, to respective resource. So in this case, if we grab for our number, we're going to see, that's a type layout and it's activity main. So bam. Okay. Once you have this association, okay, it's a layout activity main, then you can try to find it. Should be layout and then activity main. And now that's XML for the activity main. So now we know how to go from a weird number to the public.xml to find a mapping name and to the actual resource. Okay, I'm pretty sure this thing should be, yeah, there are many strings here, and the code may use these integers instead of the actual string. And how do we figure out which string maps to this string? So for example, let's say this this weird ABC font family display, let's say that you find this integer in the in your application. Well, first of all, you figure out, okay, that's an entry of type string, and this is the name. And then we basically, I think string should be in values. Yes, you open the strings, and then you grab for the name. Here it is. So this guy, this weird number actually matches to the string sans serif. The mystery solved. Okay? Cool. Let me see if I have everything to say. Yeah, there is another utility that is actually pretty cool. Once you have the APK, it's called AAPT. This comes with the Android framework, with the SDK. So if you download the SDK, if you have the monitor and so forth, you should already have this. Launch and find, investigate where this tool is, but it should be already there. And it's a utility to dump information about an APK. That's also what I use for my own, the analysis system. And so one of the things is you can do D, stands for dumps, and then you can, for example, dump the strings. Bam. This dumps, basically, it finds all the resources of type strings and it dumps them. But it is not just about strings. You can do permissions. In this case, doesn't ask for anything. In this, but if you do, then with your own application, you're going to see that the list of permissions. And then I have this badging in my notes, which basically it's a dump of many other different things. Stuff from the manifest, for example, the package name, various versions, blah 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 blah. Okay, cool. All right, folks, that's what I had for the main demo that I want to show today. The last thing I have is a couple of notes on this them reaching out challenge. So if you check the challenge description, you're supposed to connect to an IP address, and the IP address should be, I don't remember, but it's written there. First note is this IP address does not exist outside outside the my emulator. Okay, if you Google for it, you're going to figure out that it's a special IP, and this IP maps to localhost on the emulator. So what's happening once you run the challenge is that once you submit the challenge, I basically open an HTTP web server on my own system, and that IP maps to this one. If you try to connect to this IP address from your own laptop or from your device, of course, it does not work. Okay, this is to push you to actually submit an app to my system, not just go and fetch the network request. Okay, point number one. Point number two is the app, the challenge description tells you it's an HTTP server. HTTP server speaks HTTP. You're not supposed to guess how HTTP works. HTTP is a famous protocol. The entire web is built on this. Okay, it's not even HTTPS, which is more complicated. It's HTTP. Okay, if you Google, there is a crazy amount of documentation on how this thing works. So please check it out. Also, if you try to connect to it, and before trying to connect to it and say, oh, it doesn't work, well, try to, if you try to connect to google.com or to another website, this stuff should work. Actually, google.com only, I think, forces HTTPS. Eurocom.fr, I think, is still in HTTP. So you can write an app that somehow does a HTTP request to Eurocom.fr, and then you should receive back the content. Okay, if this step doesn't work, it's pointless that you try to submit an app that tries to contact my own IP address. It's not going to fly. Okay, you have a problem in your HTTP query. The second thing is, in my app, when you try to do it, as a reply, you're going to see it's a HTML form. Again, HTML form is quite well-known technology. Okay, so the idea is that you need to simulate that the user presses the button submit or the button get flagged, and you're not supposed to guess how should I reply. It's a form, it's an HTML form, and the browser, it's well encoded how, given HTML form, you should reply. So I've seen many emails, and of course, sending emails is absolutely normal. So there is no shame and no blame for this. But you're not supposed to brute force it, or you're not supposed to guess it, how you should reply. If it doesn't work, there is a reason. And today I want to show you one trick that you can use to debug this kind of stuff. Okay, so if you have an HTML page, you can, okay, let's move to another directory. Temp MOBISEC. I have a test here, but let's create another one. Peppa.html. We can create some text. Ciao, Peppa. Okay, this is a file. You can go on your browser and somehow do file / and then the full file path, tmp MOBISEC, what was it? Peppa.html. Wow, we have HTML. Okay, that's HTML rendered by your browser. If you do Ctrl+U, at least on my Linux machine, you're going to see the source code, which of course matches the file that we have. Okay. Now, in the case of a form, the browser needs to interact with the form. Okay. So what I prepared here is a test.html. Very simple. It's something very similar to what you see in the challenge. And basically, what is just text, then a form. Okay, method post, interesting, and then label. Okay, just text, and then okay, input, answer. Okay, that's where you should put your answer. And then look at this. There is input ID secret, interesting, secret value, type hidden, so you're not going to see it, value 42, whatever, and then the actual button with the submit. So what happens if we open this in a browser? Well, let's see it. Oh, let me keep it open. Okay, this looks like a form. And again, if you Ctrl+U, you're going to see that's exactly the content of the file. Again, what I'm showing you is how to be independent. You can create a file on your machine, and then you go to your Chrome, Firefox, whatever your favorite browser is, and you can traverse it and actually see the output. Okay, and the beautiful part here is, let's say we want to reply with 666. You do submit. Now, in this case, it crashes because the target of this form is going to go to /answer, which of course does not exist on my machine. Okay, but the cool part is that you can see what the browser is sending. How? With the Chrome developer tools. So here I just refreshed, press F12, or if you don't take, if the F12 doesn't work, usually I can do maybe expect, and then you do, I usually do network. Here, basically, you're gonna find a recording of what your browser is sending once it's replying to things. So if I do 666 and I do submit, bam, look at this. Now we do stop. And now this basically was our request. And here you can see headers, and you can see form data. And basically that's what the browser actually sent to the server. Okay, so it didn't only send the answer, it also sent other stuff. What is other stuff? Well, maybe somehow related to what's in the form. You know, I think I've said too much. What I'm trying to say here is you can try to simulate what the real browser would send, and that's the goal of the challenge. You should submit a post request simulating what the real browser would actually send. Okay. Again, I think I said too much about the challenge. You know, this is a good trick. So independently from the challenge, maybe it's going to be easier. You know, it's a good trick to debug things. This kind of recording with Chrome. So I hope it's going to help you out. Okay. So that's what I have for today. Again, was a quick one. I apologize again for the delay, for sending it late. I expect the next recording on Tuesday to be absolutely in time, since I'm getting used to this new environment. And you know, good luck with the homework. If you're stuck with something, email me, and you know, nothing too bad can happen, and I'll do my best to reply in a timely manner. Okay. All right. Bye bye.